Hello, welcome to Universe Drift. My name is Adam, and I'm honored you're here. In this moment, right now, you're safe. Your only job is to settle into your pillow, to let your body relax, to breathe. I'll be your companion through the darkness, through the stars, all the way into sleep. You're exactly where you need to be. Let's go there together. Imagine, if you will, that you are standing beneath the night sky. But this is not the sky you know from your childhood, not the flat dome sprinkled with distant points of light. No, tonight, you are standing at the edge of a great ocean, an ocean made not of water, but of time itself. Each star you see above you is not simply a ball of fire hanging in space. Each one is a messenger, a traveler, a piece of the past that has journeyed across the void to find you, here, now, in this exact moment of your life. The light that touches your eyes tonight left its home long, long ago. Before you were born, before your grandparents were born, before the first human being ever looked up and wondered what those lights were. Some of that light has been traveling for thousands of years, some for millions, some for so long that the star that sent it no longer exists. You are not looking at the stars, you are looking back through time, back through the great river of history. You are seeing echoes, beautiful, luminous echoes, suspended in the sea of time. And tonight, we are going to follow one of those echoes back to its beginning, back to the moment before it was a star at all, back to when it was nothing but a whisper in the dark. Let your breathing slow now. Let each breath become deeper, heavier, as if you are sinking down through layers of atmosphere, through the thin blue skin of Earth and out into the black velvet silence beyond. We are traveling now, not forward, but backward through time, through the years, through the centuries, through the millennia. We are leaving behind the world of clocks and calendars and entering a place where time moves like honey, thick, slow, ancient. And there, far from the light of any sun, far from the warmth of any world, there is a place we are going to visit, a sanctuary, a womb, a cloud of dust drifting in the dark. Let us go there now. In the beginning, there is nothing but the dark. Not the darkness of a room with the lights turned off, not the darkness behind your closed eyelids. This is a deeper dark, an older dark, the kind of darkness that existed before the first light was ever born. It is cold here, colder than any winter you have ever known, colder than the deepest ocean trench, colder than the space between thoughts. The temperature here is only a few degrees above absolute zero, the point at which all motion ceases, where even atoms forget how to tremble. yet, this place is not empty. If you could open your eyes here, if eyes could even exist in this place, you would see something faint, something almost invisible. A haze, a mist, a cloud so thin, so delicate, that it barely disturbs the vacuum of space. This is a nebula, a nursery, a womb of silence. It stretches for light years in every direction, distances so vast that even light, racing at its impossible speed, would take decades to cross from one edge to the other. And within this enormous, gossamer cloud, there are trillions upon trillions of tiny grains of dust. Each grain is smaller than a particle of smoke, smaller than a mote of pollen drifting through a sunbeam. Some are made of carbon, the same element that forms the graphite in a pencil. Some are made of silicates, the same minerals that make up sand on a beach. Some are made of frozen water, ice crystals no bigger than a bacterium. They drift. They have been drifting for a very, very long time. How long? It is difficult to say. Time in this place does not move the way it does for you and me. There are no days here, no seasons, no years. There is only the endless, patient drift through the dark. Perhaps these particles have been drifting for 10 million years, perhaps 100 million, perhaps longer. They do not hurry. They have nowhere to be. They simply exist, floating, tumbling, slowly spinning through the cold in the great silence between the stars. And nothing happens. For eons, nothing happens. This is the philosophy of waiting, the practice of patience on a cosmic scale. These particles do not wonder when their purpose will arrive. They do not grow restless. They do not doubt. They simply wait, suspended in the dark, like seeds buried in winter soil, waiting for a spring that may never come. But waiting, as it turns out, is not the same as emptiness, because even here, in this cold and silent place, there is something at work, something invisible, something patient and slow and utterly inevitable. There is a longing. We call it gravity, but that word is too small, too clinical, too mechanical for what is actually happening here. It is not a force in the way we usually think of forces, something that pushes or pulls with violence or intention. No, it is subtler than that. It is more like a song, a whisper, a gentle insistence that travels from particle to particle through the fabric of space itself. Each grain of dust, no matter how small, carries within it this longing, this quiet desire to be near another, to touch, to merge, to belong. And so slowly, oh so slowly, the particles begin to drift toward each other. Imagine two specks of dust, each no bigger than a virus, separated by a distance of several miles. The longing between them is so faint, so delicate, that it would take thousands of years for them to drift close enough to touch. But they do. Eventually, they do. And when they touch, they cling. They do not bounce apart. They hold on to each other, these two tiny grains, in the vast emptiness of space. And now they are no longer two. They are one. A slightly larger speck with a slightly stronger longing. And this new speck calls out silently to other specks nearby. And they come. Not quickly, never quickly, but they come, grain by grain, mote by mote. Over millions of years, the cloud begins to thicken in certain places. The dust gathers. It clumps. It forms delicate, gossamer threads that twist and coil through the nebula, like the slow, dreaming thoughts of some vast, sleeping mind. And at the center of one of these threads, something is beginning to happen. A knot is forming. At first, it is almost nothing, a slight increase in density, a place where the dust is just a little thicker, a little more concentrated than the surrounding cloud. But this is enough, because now the longing grows stronger. The knot begins to pull more insistently on the dust around it. Particles that were drifting peacefully, aimlessly through the dark, suddenly find themselves drawn toward this place. They spiral inward, slowly at first, and then faster, faster, pulled by the growing mass at the center. And as they fall inward, something extraordinary begins to happen. They heat up. This seems impossible. How can something grow warmer by collapsing? How can falling inward create heat in the coldest place in the universe? But it does, because motion is heat. And as the particles fall, they accelerate. They collide with each other, billions upon billions of tiny impacts, each one releasing a microscopic amount of warmth. And those microscopic amounts begin to add up. The knot grows warmer, and as it grows warmer, it begins to glow. At first, the glow is so faint that no eye could ever see it. It is infrared, heat without light, a deep, invisible warmth radiating from the center of the collapsing cloud. But the collapse continues. More dust falls inward, more mass accumulates. The center grows denser, hotter, brighter. Time passes, 1,000,000 years, 2,000,000, 5,000,000. The cloud is no longer a thin, gossamer haze. It is contracted, pulled inward by its own longing, until it forms a disk, a flat, spinning wheel of dust and gas, with a dense, glowing core at its center. This core is called a protostar. It is not yet a star, not truly. It is still gathering, still growing, still waiting for the moment of its true awakening. But that moment is coming. Deep within the core, the temperature is rising, the pressure is building, atoms are being crushed together with such intensity that they can no longer remain separate. They begin to merge, to fuse. And when that happens, when the first two hydrogen atoms, pressed together by the unimaginable weight of the mass above them, finally surrender and become one, when the first burst of energy is released from that fusion, that is the moment. That is the birth. It does not happen all at once. It is not a sudden explosion. It is not a switch being flipped. It is a gentle transition, a slow kindling, a whisper that gradually becomes a song. Deep in the core, the temperature reaches 10 million degrees. At this temperature, hydrogen atoms, those simplest, most ancient of atoms, each one made of a single proton and a single electron, are moving so fast, colliding with such force, that something miraculous happens. They break through the invisible barrier that usually keeps them apart. They touch, they merge. Two hydrogen atoms become one helium atom. And in that merging, a tiny amount of mass is lost. It does not disappear. Nothing in the universe ever truly disappears. Instead, it transforms. It becomes energy. Pure, radiant energy. Light. This is the first heartbeat of the star. A single fusion reaction, releasing a single photon of light into the dark. But one heartbeat is followed by another, and another, and another. Soon, billions upon billions of hydrogen atoms are fusing every second. The core is alive with this new fire. Energy pours outward from the center, pushing back against the crushing weight of the gas and dust, still trying to collapse inward. For the first time, the star reaches a balance. The inward pull of gravity, the great longing, is matched by the outward pressure of the fire within. The star stops collapsing. It stabilizes. It opens its eyes, and it begins to shine. The light that is born in the core does not immediately escape into space. It cannot. The star is too dense, too thick with matter. The photons of light born in the furnace at the center must fight their way outward through layer after layer of hot, compressed gas. They are absorbed and re-emitted, absorbed and re-emitted, bouncing from atom to atom like a pinball in a machine made of fire. A single photon born in the core may take 100,000 years to finally reach the surface and escape into space. But eventually, it does. The surface of the star, the photosphere, the glowing skin, begins to radiate light outward in all directions. Light that has been struggling, fighting, clawing its way upward through the interior, finally breaks free and rushes out into the void at the speed of, at the speed of itself. The star is born. It is small by stellar standards. Not a giant, not a behemoth. It is modest, humble, perhaps 8/10 the mass of our own sun. A common type of star, one of billions in the galaxy. But to itself, it is unique. It is singular. It is the only star in the universe that is itself. And now, it begins the longest chapter of its life, the chapter we call the long noon. But that part of the story is still to come. For now, let us simply rest here in this moment of awakening. Let us linger in the soft, newborn glow of this young star as it takes its first breath, as it steadies itself in the dark, as it begins its watch over the cosmos. It has been born from dust. It has ignited from cold. It has become light. And it is beautiful. Time passes, not the way it passes for you, lying here in the warmth of your bed, breathing softly in the dark. Not the way it passes when you wait for water to boil, or for a season to change, or for a wound to heal. Time passes the way it does for mountains, for oceans, for continents drifting across the face of a world. Slowly, patiently, with a kind of eternal, unhurried grace. The young star settles into itself, the wild fluctuations of its birth, the surges and pulses, the flickering uncertainties of new fusion, gradually smooth out into something steady, something reliable. The fire at its core finds its rhythm, like a heart that has learned to beat at exactly the right pace. In the furnace at the center, hydrogen continues its ancient alchemy, transforming into helium, releasing light and heat in a steady golden stream. 4 hydrogen atoms become 1 helium atom again and again and again. 600 million tons of hydrogen fuse into helium every single second. And yet, the star does not diminish. It does not weaken. It has so much fuel, such vast reserves of hydrogen, that it could burn like this for billions of years without growing dim. And that is exactly what it does. It burns. It shines. It enters what we call the main sequence, that long, stable period of a star's life when nothing dramatic happens, when there are no explosions or expansions or collapses, when the star simply is. This is the long noon, the endless golden hour. The star has become a watcher in the sky. But the star is not alone in the darkness. Around it, in the disk of dust and gas left over from its birth, something else is happening. Something quiet. Something patient. The disk is still there, still spinning, a flat wheel of material orbiting the newborn star. And within that disk, the same process that created the star is happening again, but on a smaller scale. Dust grains collide and stick together. Pebbles form, then rocks, then boulders. These larger pieces have more mass, and so they pull on the smaller pieces around them, gathering them in, growing larger still. Over millions of years, these accumulations become worlds, planets. Some are small and rocky, forged from iron and stone, baked hard by their proximity to the star's warmth. They huddle close to their parent, orbiting in tight, swift circles, completing a year in what would be mere weeks or months on Earth. Others form farther out where the disk is colder. Here, ice can survive. Water ice, methane ice, ammonia ice. These worlds gather not only rock and metal, but also vast envelopes of gas, hydrogen and helium, the primordial elements. They become giants, worlds so large that hundreds of Earths could fit inside them. And around some of these worlds, smaller disks form. And from these smaller disks, moons are born, worlds orbiting worlds. A system emerges, a family. The star at the center watches as its children take shape in the disk around it. It does not know they are there. It has no consciousness, no awareness, no sense of self or other. But its light touches them, warms them, illuminates them, and they, in turn, reflect that light back into the darkness, like children learning to sing by echoing the voice of a parent. The star shines on. Let us imagine for a moment what the star sees. Not with eyes, it has no eyes. Not with thoughts, it has no mind. But if we could somehow experience the universe from the star's perspective, if we could feel what it feels as it hangs suspended in space, burning steadily decade after decade, century after century, what would we witness? First, we would see the planets in their orbits, the small, rocky worlds sweeping past in their swift circuits, year after year after year. The giant worlds moving more slowly, taking decades or centuries to complete a single orbit. We would watch as these worlds settle into their rhythms, watch as the rocky planets cool and harden, their surfaces solidifying from molten seas into crusts of stone. Watch as asteroids and comets, left over from the formation of the system, rain down on these young worlds, delivering water and organic molecules, the building blocks of complexity. On one of these worlds, a blue-green jewel, neither too close to the star nor too far away, something extraordinary happens. Life begins. It starts simply, a single cell perhaps, floating in a warm, shallow sea. A tiny bubble of chemistry that has learned to make copies of itself. It divides, it multiplies, it spreads, and the star watches. It does not know what life is. It does not understand the significance of what is happening on that small, wet world. But its light falls on the surface of the oceans. Its warmth drives the winds and the currents. Its energy is captured by the first primitive organisms, those simple cells that learn to harvest light and turn it into food. The star feeds them, nourishes them, allows them to grow. Millions of years pass. The simple cells become more complex, They learn to work together. They form colonies, tissues, bodies, creatures that swim through ancient seas, creatures that crawl onto land, creatures that take to the air. Forests spread across continents. Oceans teem with life in forms beyond counting. And still, the star shines on. It watches as ice ages come and go, as continents drift apart and collide, as mountains rise and erode back into sand. It watches as species emerge and flourish and vanish, replaced by new forms, new experiments in the art of survival. And then, after billions of years, something happens on that blue-green world that has never happened before in this star system. One of the creatures looks up. Imagine that moment. A being, perhaps covered in fur, perhaps standing upright on two legs, perhaps sheltering in a cave or on a savanna under the vast bowl of night, lifts its head and looks at the sky and sees the star, not just as a point of light, not just as a brightening in the darkness, but as something significant, something worthy of attention, something mysterious. This creature does not understand what the star is. It does not know about fusion or hydrogen or the physics of light, but it senses something, a connection, a relationship. The star is always there, night after night. If the sky is clear, the star appears in the same place. It moves across the sky in a predictable pattern. It is constant, reliable, eternal. The creature begins to use the star to navigate, to find its way home after long journeys, to mark the changing of seasons. The star becomes useful, and as generations pass, as this creature's descendants evolve and spread and develop language and culture, the star becomes more than useful. It becomes meaningful. They give it a name. They tell stories about it. They imagine that the star is a god, or the eye of a god, or the campfire of ancestors who have died and gone to live in the sky. They create myths to explain why the star shines, why it moves, what it watches over. They build temples aligned with the stars rising. They compose songs about it. They use it to guide their ships across dark oceans, trusting that as long as they can see that steady light, they will not be lost. The star does not know any of this, of course. It simply continues to burn. But there is something beautiful in this, isn't there? Something poignant. This vast, ancient being of fire and light, burning for billions of years in the emptiness of space, becomes loved, becomes becomes seen, becomes woven into the stories of tiny creatures on a tiny world who live for mere decades, whose entire civilizations rise and fall in what is, to the star, the blink of an eye. And civilizations do rise and fall. The star watches as the creatures on the blue-green world, let us call them humans, for that is what they call themselves, learn to plant crops, to build cities, to wage wars, to create art and music and philosophy. It watches as they invent writing, as they record their thoughts on clay tablets and papyrus scrolls and paper pages. Some of these writings mention the star. Ancient astronomers, gazing up from mud brick observatories, track its position with meticulous care. They notice that it does not wander like some of the other lights in the sky, the planets, which they call wanderers. The star is fixed, steadfast, a marker against which all other movements can be measured. They call it different names in different languages. Some call it the guardian, some call it the eye of heaven, some call it the northern fire, or the sailor's friend, or the eternal one. But always they look to it for guidance. A sailor lost on a dark sea finds the star through a gap in the clouds and knows which way to steer. A traveler crossing a desert at night uses the star to maintain direction when the sand has erased all other landmarks. A farmer, watching the star's position change gradually over the course of a year, knows when to plant and when to harvest. The star becomes part of the fabric of their lives. And the star continues to shine. It does not grow tired. It does not falter. Night after night, year after year, century after century, millennium after millennium, it pours its light out into the void. And some of that light falls on the blue-green world. And some of that light is seen by human eyes. The civilizations change. Empires rise from dust and return to dust. Languages are born and die. Technologies are invented. The wheel, the printing press, the telescope, the computer. Humans eventually figure out what the star actually is. They learn about nuclear fusion and stellar evolution. They measure the star's distance, its temperature, its mass. The star stops being a god and becomes a subject of scientific study. But even then, even when the mystery is supposedly solved, people still look up at it with wonder, because understanding what something is does not diminish its beauty. And through all of this, through the rise and fall of species, the drift of continents, the evolution of life from single cells to conscious beings who build rockets and write poems, the star remains constant. This is its gift. In a universe of chaos and change, where everything is always in motion, always transforming, always becoming something other than what it was, the star is an anchor. It is the still point, the steady flame. For billions of years, it burns at almost exactly the same brightness, the same temperature, the same color. The fusion reactions in its core are so perfectly balanced, so exquisitely stable, that the star hardly changes at all. From the perspective of the human civilizations that rise and fall on the planet below, the star is eternal. It was there before the first human was born. It will be there, they assume, long after the last human has died. And in a sense, they are right. The star has been shining for 4 billion years, perhaps 5 billion, and it will continue to shine in the same steady way for billions more. But not forever. Nothing lasts forever. Not even stars. Deep within the core, something is changing. Something so gradual, so slow, that it will take millions of years before the effects become visible. But the change has already begun. The hydrogen fuel, abundant as it seemed, is not infinite. The star has been burning 600 million tons of hydrogen every second for billions of years. And slowly, inexorably, the supply is running low. In the very center of the core, where the temperature is hottest, where the fusion is most intense, the hydrogen is being depleted, converted into helium. And helium does not fuse at these temperatures. Helium is ash, waste, the dead remnant of burned fuel. A core of helium ash is growing at the center of the star. And when that core becomes large enough, when the hydrogen fuel in the center finally runs out, the long noon will come to an end. The star will begin to change. But that moment is still far in the future. For now, the star continues its watch. It shines on the blue-green world. It guides the ships. It marks the seasons. It appears in the poems and songs and prayers of the creatures below. It is the faithful companion of a world in motion, the steady heartbeat of a living system, the watcher in the sky. And as you lie here, breathing softly in the dark, perhaps you can feel that same constancy, that same steady presence, your own heart beating its reliable rhythm, your breath flowing in and out like a tide, the solid earth beneath you turning slowly through space, cradled in the light of its own star. You too are part of this ancient dance. You too are watched over. And for now, all is well. All is steady. All is as it should be. The star burns on. For billions of years, nothing changed. And then, slowly, so slowly that no single lifetime could perceive it. Everything begins to change. Deep in the core of the star, in that dense, hot center, where hydrogen has been fusing into helium for eons, the fuel is running low. The vast ocean of hydrogen that seemed infinite has been converted, atom by atom, into helium ash. And this ash, this spent fuel, does not burn at the temperatures that exist in the core. Not yet. The helium atoms sit there, inert, accumulating, a growing sphere of dormant material at the very heart of the star. And as this helium core grows, something shifts. The core can no longer support itself through fusion. The outward pressure of the fire within begins to weaken. And so, slowly, the core begins to contract, to compress under its own weight. This contraction generates heat. As the core squeezes tighter, the temperature rises, and this heat radiates outward into the shell of hydrogen gas that surrounds the core. Hydrogen that has not yet been burned, that has been waiting patiently in the layers above the center. This shell of hydrogen, now heated to even higher temperatures than before, begins to fuse, faster, more intensely. The star, which had been burning steadily for billions of years, suddenly finds new fuel, not in the core, but in a shell around the core. And this shell burns with a fierce, bright urgency. The star begins to brighten. Its luminosity increases, slowly at first, imperceptibly, but then faster, doubling, tripling over the course of millions of years. And as it brightens, something else happens. The outer layers of the star, those vast envelopes of gas that surround the fusion shell, the atmosphere of the star, begin to expand. They swell, they loosen, they drift outward like a slow exhalation that lasts 1,000,000 years. The star is becoming a red giant. There is no violence in this transformation, no explosion, no rupture, no sudden catastrophe. It is a surrender, a letting go. The star, which has held itself together so tightly for so long, maintaining that perfect balance between the inward pull of gravity and the outward push of fusion, now releases its grip. The outer layers, no longer held as firmly by the gravitational pull of the core, begin to drift. They expand outward in a slow, graceful bloom, like a flower opening in the warmth of a late afternoon sun. As the layers expand, they cool. The surface of the star, that glowing photosphere, moves farther and farther from the hot core beneath. And as it moves outward, it cools from the yellow-white heat of the star's youth to something softer, amber, orange, deep sunset red. The star is no longer a bright, fierce point of light. It has become something vast and gentle, a luminous sphere of red-orange light, hundreds of times larger than it once was. If you could see it from the blue-green planet, if there were still eyes there to see, the star would dominate the sky. It would appear not as a distant point, but as a great glowing disk, filling a quarter of the heavens, bathing the world in a soft, amber twilight. But the planet, if it still exists, has changed too. The star's expansion has brought its outer layers closer to the worlds that orbit it. The innermost planets, those small, rocky worlds that once orbited close to the star's heat, have been swallowed entirely, consumed by the expanding atmosphere. They spiral inward through the tenuous outer layers of the giant star, dragging through gas that is still thousands of degrees hot, until finally they vaporize, their atoms scattered and mixed into the substance of the star itself. The blue-green world, if it survives at all, is scorched. Its oceans have long since boiled away. Its atmosphere has been stripped by the relentless wind of radiation. It is a dead world now, a cinder, baked to sterility by the star's old age. But the star does not mourn this. It does not know what it has destroyed. It simply continues its slow transformation, expanding outward, cooling, reddening, entering this new phase of its existence with the same patient inevitability it has shown throughout its long life. There is a lesson here in this phase of the star's life, a teaching that the universe offers if we are quiet enough to hear it. The star is not dying, not yet. It is softening. All its life it has been a tight fist of fire, holding its energy close, burning with fierce, focused intensity. But now, in its age, it releases that grip. It loosens. It breathes outward. It becomes generous with its warmth. The red giant phase is the star's giving. It pours energy out into the surrounding space at a rate far greater than it ever did in its youth. Its luminosity has increased by hundreds or even thousands of times. It is brighter now than it has ever been. And yet, paradoxically, it is cooler, softer, gentler. The light it emits is no longer the harsh, blue-white glare of youth, but a deep, warm, amber glow. The kind of light you might see on an autumn evening when the sun hangs low on the horizon and the world is painted in gold and rust and copper. There is a melancholy to this light, a bitter sweetness, because this softening, this generosity, comes at a cost. The star is burning through its remaining fuel at a prodigious rate now. The shell of hydrogen surrounding the inert helium core is fusing faster and faster, driven by the rising temperatures. And eventually, inevitably, that hydrogen shell too will be exhausted. But before that happens, before the final act of the star's life begins, There is a long period of stability in this red giant phase, a time when the star, vast and luminous and soft, hangs in space like a glowing lantern, warming the darkness around it. Time passes, millions of years. The star slowly drifts through space, orbiting the center of the galaxy along with billions of other stars. It moves through clouds of dust and gas. It passes by other star systems. Perhaps it even has companions, other stars born from the same nebula that orbit around a common center of gravity, bound together by the ancient longing that first brought their dust clouds together billions of years ago. If there are such companions, they see the star's transformation. They watch as their sibling swells and reddens, and perhaps, in time, they too will undergo the same change. But for now, the red giant drifts on. Deep within the star, the helium core continues to compress, smaller, denser, hotter. The pressure at the center becomes enormous. The helium atoms, which have been inert for millions of years, are now being squeezed so tightly that they can barely move. They are packed together in a configuration called electron degeneracy, a state where matter itself begins to behave in strange, quantum ways. And then, when the core temperature reaches 100 million degrees, 10 times hotter than the temperatures that ignited hydrogen fusion all those billions of years ago, something miraculous happens. The helium begins to fuse. 3 helium atoms come together in a rare, delicate reaction and form a single atom of carbon. Sometimes a 4th helium atom joins them, creating oxygen. The core ignites, but not slowly, not gently, not with the gradual kindling that marked the star's first birth. This ignition happens in a sudden flash, a helium flash, a runaway fusion reaction that releases enormous amounts of energy in a matter of seconds. For a brief, terrifying moment, the core of the star burns with a fury equal to the entire luminosity of 100 billion stars. But this energy cannot escape. It is trapped within the dense, degenerate core, absorbed by the helium itself. The flash happens in darkness, in silence, invisible to the outside universe. And then, just as suddenly, it stabilizes. The core settles into a new rhythm. Helium fuses steadily into carbon and oxygen. The star has found a new source of fuel, a new balance. The outer layers, which had swelled to enormous size, contract slightly. The star shrinks just a little. Its color shifts from deep red to orange. It has entered a new phase of stability. Not as long as the long noon. Helium fusion cannot sustain a star for billions of years, only for millions, but stable nonetheless. The the star burns on. It has adapted. It has found a way to continue, even as its original fuel was exhausted. This is resilience. This is the art of transformation. But even this new fuel will not last forever. The helium in the core, like the hydrogen before it, is finite. It burns faster than hydrogen did. The star must work harder now to support itself, to push back against the relentless inward pull of its own gravity. The core of carbon and oxygen grows. The ash of helium fusion accumulates, and the star continues to expand. Slowly, steadily, over millions of years, it swells again. Its outer layers drift farther and farther from the core, thinning, cooling, becoming almost transparent. The star is now shedding itself. Little by little, breath by breath, it releases its outer atmosphere into space. Stellar winds, streams of gas and dust, flow outward from the star's surface, carrying matter into the interstellar medium. This matter, carbon, oxygen, nitrogen, and traces of heavier elements, all forged in the nuclear furnaces of the star's core, drifts out into the darkness. It will become part of the next generation of stars, the next generation of planets. Perhaps someday it will become part of living beings, creatures who will one day look up at the sky and wonder where they came from. The star is giving birth to the future. This is its final act of generosity. It is returning what it took from the nebula so long ago. The dust that gathered to form the star is being released back into space, enriched now with new elements, new complexity. The universe is richer for the star's existence, and as the outer layers drift away, as the atmosphere thins and disperses, the core is slowly revealed. The heart of the star, the ancient furnace where all the fusion happened. A small, dense sphere of carbon and oxygen, no longer burning, no longer fusing, simply radiating heat accumulated over billions of years. This is what remains. This is what the star has become. The outer layers are gone now. They have drifted away into space, forming an expanding shell of glowing gas. A planetary nebula, it will be called by astronomers of distant worlds, though it has nothing to do with planets. It is simply the exhaled breath of the star, illuminated by the fierce ultraviolet light of the exposed core. This nebula is beautiful. Wisps and tendrils of gas, glowing in shades of green and blue and red, sculpted by magnetic fields and stellar winds into shapes that seem almost intentional. Rings and shells and intricate structures that look like cosmic flowers, or butterflies, or hourglasses. But we are not focusing on the nebula. We are focusing on what remains at the center, the core. It is small now, smaller than the star has been since the days of its birth, about the size of the blue-green planet that once orbited it, though far more massive. A ball of carbon and oxygen compressed to densities that seem impossible. A teaspoon of this matter would weigh as much as a car. And it is white, brilliantly, intensely white. Not from fusion. There is no fusion happening here anymore. The temperatures are not high enough. The pressure is not sufficient. The carbon and oxygen atoms sit locked in their crystalline lattice, unable to merge, unable to burn. The whiteness comes from heat alone, the heat of memory. This core, this remnant, is called a white dwarf. But that name seems too small, too clinical for what it actually is. It is a monument, a testament, a memorial carved from light and time. For billions of years, this core has been the engine of the star. It has been the furnace where hydrogen became helium, where helium became carbon and oxygen. It has been the source of all the light that bathed the worlds, that guided the sailors, that appeared in the myths and songs of civilizations. And now, its work is done. It no longer burns. It simply remembers. The heat that radiates from its surface, heat so intense that the dwarf glows white hot, hotter than the surface of the star ever was during the long noon, is not new heat. It is not the product of fusion or fission or any ongoing process. It is leftover heat, the accumulated warmth of billions of years of fusion, slowly radiating away into the darkness. The white dwarf is glowing with the memory of the past, and it will continue to glow, growing gradually dimmer, gradually cooler, for billions of years more. Longer, perhaps, than the star spent in its active life, longer than the universe has existed so far. It will fade from white to yellow to red to brown, cooling slowly through the spectrum until finally, trillions of years from now, it becomes a black dwarf, a cold, dark cinder drifting through space, invisible, inert, a piece of diamond floating in the void. But that final darkness is still inconceivably far in the future. For now, the white dwarf shines. And the matter that drifted away, the outer layers of the star now forming that beautiful nebula, continues to expand outward. The nebula grows larger, thinner, more diffuse. The glowing gas, lit by the dwarf's radiation, gradually fades as it spreads out and cools. Eventually, after thousands of years, the nebula becomes invisible. The gas merges back into the interstellar medium, the great reservoir of matter that fills the space between the stars. And there, drifting in the dark, that matter waits. It mingles with other gas, other dust, the remnants of other stars. Clouds merge and mix, stirred by the explosions of supernovae, pushed by stellar winds, pulled by the gravity of passing stars. And someday, perhaps 1,000,000 years from now, perhaps 100 million, that gas will drift into a region where the density is just slightly higher than average, where the temperature is just slightly lower, and the gas will begin to clump, to gather, to collapse, and a new star will be born. Perhaps many new stars. And around those stars, planets will form. And on those planets, perhaps, life will emerge. Creatures who are made, in part, from the carbon forged in the core of this star. Creatures who breathe oxygen created in the helium-burning shell. Creatures whose very bodies are built from stardust. They will look up at the sky and see stars. They will wonder where they came from, and they will not know. Not at first, not for a long time, that they are looking at their ancestors, that every atom in their bodies was once part of a star, that they are the children of light. This is the cycle. Dust becomes star, star becomes dust, dust becomes star again. Nothing is ever lost, nothing is ever destroyed. Matter and energy simply transform, flowing from one state to another, dancing through forms that seem distinct but are all part of the same great pattern. The universe is not a place where things are born and die. It is a place where things change, where forms arise and dissolve and arise again, like waves on an ocean, each one unique, each one temporary, each one part of the eternal flow. The star, our star, the one we have followed from its birth in the cold nebula to its final form as a glowing dwarf, has completed its journey. It has lived. It has shone. It has watched over worlds and guided travelers and illuminated the darkness. And now it rests, not in oblivion, not in nothingness, but in the quiet glow of its own history, radiating the heat of its long life back into the cosmos. It is a light that will shine for eons yet to come, a gentle, steady presence in the darkness, a reminder that even after the fire has gone out, the warmth remains. And you, lying here in the dark, breathing softly, you too part of this cycle, the atoms in your body, the calcium in your bones, the iron in your blood, the carbon in your cells, were forged in the cores of ancient stars, stars that lived and died long before the sun was born, long before the earth existed. You are made of stardust, literally. The matter that forms you has been recycled through generations of stars, each one adding new elements, new complexity, before releasing that matter back into space to form new worlds, new life. You're not separate from the universe. You're not a stranger in the cosmos. You are part of it. You are woven into the same fabric that makes stars and planets and galaxies. You are the universe experiencing itself. And just as the star goes through its cycles, birth, life, transformation, rest, so do you. You were born. You are living. Someday, you will transform into something else. Your atoms returning to the earth, becoming part of new cycles, new forms. But nothing is lost. The cycle continues. And for now, in this moment, you are here, breathing, resting, glowing with the quiet warmth of your own existence. The story of the star is complete. From the cold, silent nebula, through the ignition of hydrogen, through billions of years of steady burning, through the expansion into a red giant, through the final shedding of layers, to the white dwarf glowing in the darkness. The journey is done. The cycle has turned. The star has returned to the dark, not as it was, not as simple dust, but as something richer, more complex, carrying within it the history of its long life. It waits now in the form of that glowing dwarf, patient as it has always been, radiating its light into the void. And the matter it released drifts in the currents of space, waiting for the moment when it will gather again, when it will feel once more the ancient longing to come together, to collapse, to ignite, waiting to become a new star, a new light in the darkness. But that is a story for another time. For now, the light rests. The cycle is complete. The star has done its work. And now it is time for you to rest too. To let your thoughts drift like dust in a nebula. To let your breathing slow like the cooling of a star. To let yourself sink into the darkness, not as an ending, but as a resting place between transformations. You have journeyed far tonight, from the cold silence before birth, through the fire of existence, to this moment of peaceful stillness. And like the star, you will shine again. But for now, rest. Let the darkness hold you. Let the silence enfold you like the vast, patient spaces between stars. You are safe. You are home. You are part of the eternal cycle. The light rests, and so do you. Thank you for trusting me with your night. That means everything. Rest well. Good night. Sweet dreams, and I'll see you tomorrow.